Hello, young math padawans. It's Mrs. Angel with your lesson for today on creating equivalent fractions using big ones. There's a lot of vocabulary in this lesson, so you might want to follow along on whatever type of notes that you have for today. Grab those notes and something to write with. Let's get started. So to start off our lesson today, I've got these two pizzas. The pizza on the left is broken up into two slices, one on the left and one on the right. And then the pizza directly next to me, the yellow one, is broken up into 6 slices, and then I've shaded in 3 of them. So my question for you is this the same amount of pizza? So is this the same amount? Well, what I'm going to do is I'm actually going to take this first pizza, and I'm going to drag it on top of the second one to see if it's the same amount. Look at that. If I drag it on top, it actually shows that it's the exact same amount of pizza, which most of you probably knew. Let's look at what that looks like as a fraction. In the first pizza, there's 1 slice out of a total 2, so that would be the fraction 1/2. In the second pizza, we have 3 slices shaded in out of a total of 6. Now, because we have the same amount of pizza, it can be said that these two fractions are equivalent. So equivalent fractions represent the same amount, the same total area, or the same just overall amount. So in this example, the pink pizza, even though it's only 1 slice, represented the same amount as the yellow pizza. So when we use this word equivalent, that's what we're talking about. So how does one actually create equivalent fractions? Well, one way to do this is to multiply by what's called a big one. So let's look at our example. We had 1/2, and we showed that it was equivalent to 3/6. Well, how was 1/2 equivalent to 3/6? Well, that's because we went from 1 slice into 3 slices. So the number of slices that we had shaded in multiplied by 3. So really what happened is we multiplied the number of slices from the first pizza by 3. And now if we follow the rules for multiplication, 1 times 3 gives us 3, and 2 times 3 gives us 6, and voila, that shows us that 1/2 and 3/6 are equivalent. But where's the big one in all of this? I don't see, the only one I see is over here, and I know that's not that big. The big one is right here. 3/3 is called a big one because 3 divided by 3 is 1. Or if I created a quick diagram and I broke it up into 3 pieces and I shaded in all 3, that represents 1 whole. So a big one is any fraction where the numerator and denominator are exactly the same. So 3/3, 4/4, 2/2, 100, 100. If the numerator and the denominator are identical, that's called a big one. So let's practice. So the directions say multiply each fraction by a big one. So we're going to create equivalent fractions. What big one do I want to use? I'm going to use 5/5. Number 1, we have 4/3. So to create an equivalent fraction, a fraction that represents the same amount of area as 4/3, we're going to multiply it by 5/5, which, if you remember, is really just multiplying it by a big one. So when we do that, what are we left with? Well, let's see. 4 times 5 is 20, and 3 times 5 in the denominator, 15. So 4/3 is equivalent to 20/15. So we want to represent that with a statement. We're just going to use an equation. We started with 4/3, and we're saying that that is equivalent to the fraction 20/15. And just how you can check your work, a couple things here. Notice how 4 is greater than 3, and 20 is still greater than 15. That kind of shows that we probably did our work correctly. And if I were to go backwards, 4 goes into 20 5 times, and 3 goes into 15 5 times. So these are what we would call equivalent. So why don't you try number 2, 3, and 4. You're multiplying it by the big one 5/5, and then you're writing out your equivalent statements. So when would we actually use this skill? Well, we use this whenever we're adding or subtracting fractions with unlike denominators. So let's say, for example, I wanted to do 4/3 minus 2/15. Remember, in order to add or subtract, those denominators have to be the same. So I would basically be looking here and going, wait a minute, I can't subtract 1/3 and 1/15, but I could create an equivalent fraction out of 4/3 that I know is equivalent to 15, and I would do so by multiplying by a big 1, 5/5. Then 4/3 could be rewritten as 20/15, which is equivalent, just with a different denominator, and then I could actually do this subtraction. So that's when you use multiplying by big ones. You use it when you're adding and subtracting with unlike denominators. Another way to create equivalent fractions is by factoring out a big one, which is also sometimes called simplifying fractions. So we have 18/10. Is there a number that goes into both 18 and 10? 2 does, right? Let's go ahead and rewrite this. And I'm going to rewrite 18 and 10 as products using 2. So 18 is 2 times 9 in the numerator, and 10 is 2 times 5. That's called factoring. Factoring means to write as a product. So now that we have factored, there's something that I notice here. Do you see it? I see a big 1. 2 over 2, or 2/2, is actually a big 1, which means we can simplify that big 1. So really, what our new expression is it's just 1 times 9/5. And what's 1 times 9/5? That just leaves you with 9/5. 9/5 is equivalent to 18/10. And you know what? That's actually called a fraction in simplest form. What's simplest form? Simplest form is a fraction where the numerator and the denominator don't have any factors in common. So let's try our second example. We have 24/30. I know 2 goes into both, so let's start with that. 24 is 2 times 12, and 30 is 2 times 15. Look at that. I see another big 1. So really, that just leaves us with 12/15. Cool. So we just made an equivalent fraction, 12/15. Is 12/15 in simplest form? I'm pretty sure 12 and 15 have a common factor. What factor do 12 and 15 have in common? That's right, they have 3 in common. So now let's factor out 3. So 12 is 3 times 4, and 15 is 3 times 5. Oh, look, another big 1. 3/3 is a big 1, and that leaves us with 4/5. And here's the cool part, or what I think is cool. We just created 3 equivalent fractions. All 3 of these fractions are equivalent. They all represent the same area, the same amount. The only difference and special part of this last one is that it's in simplest form. Okay, so now we're going to end this video by creating some equivalent fractions, factoring out big 1, and then the key word here is that we want those final fractions to be in simplest form. Let's find the simplest form of each fraction. So number 1, 9/15. What common factors do 9 and 15 have? In other words, what number goes into both 9 and 15? I'm thinking 3. So let's rewrite 9 as a product using 3. That would be 3 times 3. 3 times 3 is 9. And 15 would be 3 times 5. I see a big 1. 3/3 is really just 1, so that leaves us with 1 times 3/5. So we're left here with 3/5. Now, 3/5 is equivalent to 9/15, but is 3/5 also in simplest form? Yeah, because 3 and 5 don't have any factors in common. So I'll put a box around my final answer to show that it is in what we would call simplest form. Why don't you try 2 through 4 on your own? Now, in all three of these examples, I managed to simplify all of them in one step. Sometimes it takes students more than one step to simplify. That's because I used what's called the greatest common factor. And that, or it's called the GCF for short. And that's something that you're actually going to be going over with your teachers in your lesson for today. So just as a quick recap, big ones have the same value in the numerator and the denominator. And then, of course, to create equivalent fractions, you can either multiply by a big one, which is used when we're trying to find common denominators in adding or subtracting, or you could factor out a big one, which is what we use when we're simplifying fractions and putting them in simplest form. So your teachers are going to continue your lesson today. As for our time together, that's all, and I will see you next time.